As our data grows larger and is updated more frequently, we need to stop using static files like CSV files, and instead we need to start using a database. The best way to think about a database server is that it's a computer that lives on the internet and it's running an application that is a database application. Now, this could be Postgres, it could be Oracle, it could be MySQL. There's a whole bunch of different types of database applications, but the one thing that they all have in common is that they have very close access to the hard drives and the physical storage of the data. But fundamentally, they're just a service living on a server that I can access via the internet. And my little RStudio program running through my laptop is going to connect through the internet to a server. That's the right way to think about what a database is just something that is online 24/7, ready to ask and to serve up data whenever I want it. There's a couple of reasons to use databases. First is data freshness. Because the database has the definitive version of the data, then if I have an R script that pulls directly from the database instead of a CSV file or something like that, I'm guaranteed that the data that I'm grabbing is the most up-to-date and the definitive version of the data that I could when I grabbed it. So having your R script pull from the definitive version of the data is good practice. Second, I don't have to store the data on my local machine. My local machine doesn't have that much space in it, and it doesn't make sense to store gigabytes of data when I probably don't need it. Keep it on the server, keep it where it actually lives, and only grab it when I actually need it. And finally, databases are much more robust. The difference between a simple database and an enterprise level database is a lot of money, but critically, there are certain things that happen on a database, which is that certain actions are atomic, which means they're either done or they're not done, but not halfway in the middle. This is really important for data integrity so that the database doesn't become corrupt and all of a sudden you've lost, say, 5 minutes worth of financial transactions, which for a credit card company, that's a huge deal. So databases are the way that we make data storage enterprise ready and more robust. So as a result, we have to learn how to deal with databases. The first step in working with a database is to actually connect to the database. To do this, we'll need to know, one, where the database lives on the internet, and two, we'll need a username and a password to connect to the database so that we're authenticated and allowed to do things. In these two cases, we've got a database that is, in this case, a Maria database, and here a Postgres SQL database, but they both require the location on the internet where they live and a username and a password. In this case, we're going to use a password that we prompt the user for instead of storing our password in some sort of script that we would show to the world, which is a bad plan. Now, for our example here, we're actually going to use a database that is going to live on your personal machine because we don't have a nice toy data set that we want to work with that actually lives on the internet. Instead, we're going to start a database on my own personal machine, and we're going to access it via this con object that stands for a connection. And whenever we do a database action, we're going to need to know this connection piece in order to say, access to the database that lives on this connection. Now that our database connection is established, we're going to add a couple of tables just for some examples. In this case, we're going to go back to our credit card example from a couple of chapters ago and use these four tables: the credit card table, the customers table, retailers, and transactions. Now, just remind ourselves, we've got 4 customers, we've got 5 different credit cards, we've got some transactions, and a few retailers. Now, just to finish setting up our example, we're going to write these tables, these cards tables, to this database connection. This isn't normally how you would create a table in reality, but for a simple example, we just need to get our database set up. So after we do that, I'm going to remove my original tables just so that all we've got is our database connection con. We're going to execute our first SQL command in the following way. We're going to start by building our SQL command as a character string inside R. And then we're going to take that and we're going to use this dbi get query command, which takes the connection to the database and the SQL command as arguments. So to deconstruct the SQL command, let's start at the beginning. We have a select command, and this says that we are going to grab a particular number of columns. Now notice that this is similar to the dplyr command select, and that's actually where the dplyr got it from. So we're going to select star. Star stands for all of the columns. So this is the wildcard. And then from is a keyword that says that we are going to be telling us what table we're going to do. So this says select all the columns from the transactions table. Now there's one last thing that we could add to a SQL command, which is a where statement. And a where statement allows us to create some sort of filter command. In that case, the Boolean operators and or not can be used to create relatively complex filtering statements. I would love to be able to not remember my SQL syntax. I would love to use my regular standard dplyr manipulation tools that I know and love on a bunch of database tables. I would really love to continue to use my pipe operator. Essentially, I would love to be able to ignore the fact that a table of data lives on a database and not on my local computer. Well, the R package dbplyr is intended to essentially function as the dplyr package does, but work on database objects. It allows me to pretty much ignore that a table is on a database, with one caveat. This only works for reading data tables. This doesn't work for writing or modifying the actual data in the database. If you want to do that, you have to use the traditional SQL commands to do that. But for just doing queries, which is what most analysts will do most of their time doing, the dbplyr package works really quite well. The first thing that we need to do is to take our database connection and then make connections to individual tables in that database that we're going to use. And this is going to give us the appearance of having 4 tables that are in my working environment. But these are going to be not quite data frames. Notice here this transactions is now a list. And if we go ahead and look at, say, the first 3 observations of this thing, we're going to notice that this is in fact not a table, but it's going to be something called a lazy query. And notice that it doesn't know how many rows we actually have available. Now, the reason for this is that the guiding principle of dbplyr is that we're going to delay as much and as long as possible for actually downloading the information. The rationale is that as I'm building these queries, it's very, very easy for me to accidentally end up asking for gigabytes or millions of rows of data and when I don't actually need it. And when I have to connect through the internet to get that information, it's very slow and it's very cumbersome. So what we're going to do is that all of our manipulations are going to be delayed as long as possible. And then all of the work, as much of the work as possible, is going to be done using the server and not my local computer. So here we've got an example of a large statement that looks fairly similar. So we're going to take our customers, we're going to filter for one particular customer, and we're going to select the column for person ID. We're going to join it to our cards table. We're going to join it to our transactions table. We're going to join it to our retailers. We're going to select 3 columns, and I'm going to actually do some renaming as well. And all of this is going to work just fine. And what we're going to end up doing is creating a resulting table, but it's not actually the resulting table. This is still a lazy query. We actually haven't downloaded all of the information from the database about what's going to happen, because this could still be millions of rows. In order to actually download the information, we have to call the collect command. And that collect command says that we're already done, we're happy with our query, and we can actually execute this. And we're certain that we're not going to get gigabytes of data unless we actually want to get gigabytes of data. So this is going to be our final step to actually get the last of the information. And now this comes in as a tibble. It's a 3x3 tibble, and we've downloaded the information. It's sort of fun to see what the SQL code actually is that is being generated, because it turns out that this is not the way that I would have written this SQL if I had been writing it by hand. And you can see that there's a lot of nested selecting from that is handling my left joins. So all of my left join, left join, all of that information is getting nested in these statements right here. So it's maybe not the prettiest SQL command, but it definitely works. All right, the last thing that we need to do whenever we deal with a database is we need to actually, once we're done with our database connection, we need to close that connection. And the reason is that if we don't actually close it, then the database end of it just has this open connection waiting for some client. And if we have hundreds or thousands of clients trying to connect, then this is a bad news. And our database admin hates that. So when we're done with our database, we should close the connection. And with that, that is a quick introduction to interfacing with databases using R, and particularly using the dbplyr package.